Hey everybody, Matt Wallace bringing you AI every day. I've got a few cool things to talk about today. The first is the Databricks acquisition of MosaicML. Then I'm going to talk a little bit about open source models and the connection between base models and the RLHF trained versions and how the licenses sometimes differ. And then just point you at a few other really cool resources that I'm following that I think might be of interest to you. So the first thing was just this news that Databricks has acquired MosaicML that we heard. It was happening in the peak of Databricks' conference. Really shows, I think, Databricks' commitment to trying to drive ML outcomes and participate in that ecosystem. Mosaic was already one of the leading providers of open source LLM technology. They had a bunch of base models, up to 30 billion parameters that were open sourced with permissive licenses, I might add. And I have spent some time keeping track of who has permissive license models and how large they are. And they were one of the largest and most widely used to underpin some things. Databricks obviously has a ton of effort that they have into building, the data lake house. They are catering to some extent to an analytics crowd, people who want to run BI dashboards and do traditional analytics. As they were the people who originally created Spark as a project, they certainly play pretty well in the streaming analytics space. They're certainly no stranger to stacks that play with Spark plus Flink plus Kafka. And yet it's interesting to see them push so hard into ML. I think it's really important. I think that there's a ton of stuff to be done. I think not necessarily everything gets built on top of LLMs in the future, but I do think that there is a huge opening for commercialized applications that leverage LLMs in the future. Mosaic has a fantastic set of IP here to pick up. This leads me to a brief discussion about licensing. So Mosaic actually had one of the largest, until very recently, it was the largest permissive license open source model, the Mosaic 30 billion parameter model. Now, let me hedge two ways there. First of all, Bloom was technically a larger model. Bloom is 176 billion parameters. I don't know if this is purely because of the size or if it has something to do with the quality of the training and people aren't getting good results. I haven't seen a lot of things being built on top of Bloom. Now, neither the Mosaic 30 billion parameter model nor the Bloom 176 billion parameter model had instruction training. And by instruction training, the RLHF and other techniques that were used to refine the token predictor model into a full chatbot model like ChatGPT. This is the difference between the original GPT-3 model and a model like ChatGPT that just tends to be a lot more useful directly interacting with a human being. In Mosaic's case, there was an instruct version. And when I say instruct, that's based on the quote unquote instruct GPT paper published by OpenAI that introduced this RLHF technique and showed how it could produce really fantastic results in terms of interacting with human beings. There is an instruction trained version of the Mosaic model, but it is not as permissive. The instruct trained version is CC by SA share alike. So Creative Commons share alike license, as opposed to the base model, which is purely permissive. And of course, every license comes with some sort of requirement, more or less. But the ones that have the most permissive is things like MIT licenses, Apache, etc. What's the reason for the difference between those two models? And the short answer is that when you are doing the instruct train models, there's two things that are being leveraged to produce the final model. The first is the actual model itself and its training on its data set. People produce the models, and that is the actual code to execute on training. And then typically they're also publishing the actual trained model with all of its weights, so it's ready to actually use and do inference. And they've fed it all of the training tokens and produced the model. So you can actually, if you have the training data, right, all things like open text, Common Crawl, Wikipedia, etc., you can feed that and you can actually do the training yourself. You rarely want to because it's incredibly costly from a compute perspective. These are the kinds of things where on the really high end, you hear about it taking 10,000 GPUs for a month or more. With things like Mosaic, is that the instructions that are being used, the RLHF, reinforcement learning with human feedback examples that are being added on top of the base model, which is a much easier pass, by the way, and computationally far less expensive. But those things that are being layered onto that, those are not licensed permissively. And so you take the permissive model, you do less permissive RLHF training on top, you end up with an instruction trained model that now no longer has a permissive license, because the interpretation people have is that applying RLHF with those instruction sets is something that sort of converts the model into the least permissive license. You saw this happen with Databricks themselves with their original model, Dolly, that they published, which was based on a different open source model and permissive, and they instruction trained it, but the instruction training they used was a less permissive model. And so it was open source, but it was not really suitable for certain types of commercial purposes because you'd have to publish what you were doing with it. You look at the Dolly version 2, Databricks replaced the RLHF examples they used from a different open source set that was not permissively licensed. They say crowdsourced 10,000 examples from inside Databricks. I talked about that on a previous episode. That led them back to having a truly permissive model. So same thing with Mosaic, 30 billion parameter base model, totally permissive license. Instruct trained version, a less permissive license, which leads me to a funny tidbit. And one of the resources that are worth seeing, and I'll flash up a screenshot of it for you here, but Hugging Face maintains an open LLM leaderboard. It's pretty useful so you can see who's quote unquote winning in terms of different types of LLM evaluation benchmarks, who's in the lead. One of the ones that just recently came out that's been announced is one called Falcon 40 billion parameter instruction trained. So the Falcon 40 billion parameter example is permissively open sourced, including with the instruction training. 40 billion parameters makes it a fairly large model, and it's currently topping that leaderboard. I used to actually have a Google spreadsheet someone was maintaining that had a set of the open LLMs. Actually, it had set all the LLMs, what was known about them, but I was using it mostly to keep track of the ones that were open to form the base for any kind of commercial. But the open LLM leaderboard is a great place to go. Now that includes non-permissive open source licenses. So you have to understand what's going on with those. And you've got that new champion Falcon 40 billion parameter models in there. Another thing I wanted to point out today, just someone who I think has just given me so much in terms of knowledge in the space, who just seems positively brilliant and totally in touch with the things that are going on, is Sebastian Roschka. Sebastian is one of the people behind Lightning makes a PyTorch module that is powerful for training and optimizing LLMs and vision models for ML. But he regularly posts on LinkedIn. It's incredibly instructional. It's relatively technical, but I think pretty approachable. And you actually can follow the high level, I get what's going on here version of his LinkedIn posts and just understand what he's saying. And then also morph that over to the kind of deeper papers that dive in a little bit more, sometimes in source code examples, etc. I'll flash one up that he posted just a couple of days ago, which I think was really interesting. And it's talking about how LLMs can be really difficult to deal with on lower end hardware. Like in this case, consumers. And I at home run an RTX 4090. It is the most powerful consumer graphics card you can buy, packs 24 gigabytes of video RAM. And so I'm able to easily run things like Stable Diffusion locally, even with all kinds of add-ons, without having to boil down the precision. But I have no chance of loading and running something like a Bloom model. So that having been said, I think Sebastian is extremely worth following because there's just a ton of knowledge here that gets into the technology behind LLMs, as well as techniques for really accelerating the training and inference in a super practical way. And of course, check out PyTorch Lightning. Please follow me, like, subscribe, and keep up with what's going on.